Welcome everyone to geometry. We want to start off with the preliminaries, so the first section of our text. And we want to get into the basics of set theory. Now, this is something that likely you guys have seen already, so we're going to look over this very, very briefly. All right, so this is part one. We're in section one. Feel free to read over this little bit about Euclid of Alexandria and things you may have seen. Maybe a quick note here, since I received this content or this text from someone else. Here refers to Math 324. You should have seen these things in Math 220 or possibly many other courses. So that is what we're going to take a look at in this video, the basics of set theory. Again, this is likely something that you've seen before, but we're going to go ahead and take a very brief look at it. So, basics of set theory. A set is simply a collection of objects, right? Doesn't matter what they are. It could be a collection of automotive manufacturers, right? I like cars. That's what I think about. It could be a collection of students, the students that are registered for Math 331, right? A set is simply a collection of things, of items. It could be anything at all. And then those things that are in the set are elements of the set. So if something belongs to the set, it is an element of that set. So if we were to consider this set A being the numbers 1, 2, and 3, then we would have the notation that A is equal to curly bracket 1, 2, 3 curly bracket, right? This is set notation. And the number 2 belongs to the set A, so we would designate that by 2 belongs to A. The number 4, however, is not in the set, so we would write that as 4 does not belong to A. Okay, so some notation here that we want to be familiar with. The empty set is simply the set that doesn't have anything in it, nothing at all. That set is denoted by this symbol, a phi. If you wanted to, you could write it as curly brackets with nothing between them. You could think of that as the definition even, right? There's nothing in the set. All right, so if we have two sets and all of the elements of one are contained in the other, then we would say that one is a subset of the other. So if all the elements of one set S are contained in T, then S is a subset of T and can be designated or denoted as S is a subset of T in this way. All right, so given two sets, we can consider two operations which not necessarily join them, but joins them, but combines them in a certain way. So the union of two sets, S and T, the union of S and T, is the set of elements that appear in S, in T, or in both S and T. And we would denote the union by this. And then the intersection of two sets, S and T, is the set that is the set of elements of only those that appear in both S and T. So it's denoted by this. So there's a couple of examples here that you can take a look at. This is, again, something that I think that you guys are familiar with. So we just want to make sure or remind ourselves of what a set is, how we can designate elements of a set, how we can designate something as not an element of the set, or denote rather, what is the empty set, unions, and intersections. And that's it. So there's not going to be any homework for this section, but if I chose to, I think it would be appropriate to include such a question on an exam, right? It's something that you should be familiar with, that I could ask a question about. But that's it for this section. So pretty straightforward, pretty quick. If you guys have any questions about that, feel free to send me a message, let me know, and I'll be happy to get back with you. Otherwise, have yourselves a great day.